Hello and welcome to Global AI. My name is Chandar Dhal, commonly pronounced as Chandar Dhal. I'm the CEO of Kasten, and I'm very grateful to have the Microsoft Regional Director as well as the MVP Award and the Google Developer Expert Award. I've written a book on scalability patterns, and I've got 6 courses on LinkedIn Learning. Thank you for having me as one of the keynote speakers today, and we're going to cover the comparison of the top three clouds, AWS, Azure, and GCP, especially some of their AI offerings. And just so you know, we're not trying to say one is better than the other. In fact, all of them have to have, and they do have great strengths as well as weaknesses. If you'd like to connect with me, you can connect with me on LinkedIn. And if you have any questions regarding this presentation, please feel free to reach out to my team at info@kasten.com. All right, so let's get started. Let's talk about the agenda today. We're going to talk about scalable architecture because we've witnessed a ton of projects in the last couple of decades where scalability was an afterthought. So we like to talk about it anytime we get started on a project. We would also like to compare some of these handwriting as well as form labeling kind of AI offerings that we have in different clouds that are out there, including invoice as well as receipt recognition, which are kind of another kind of form recognition anyway. So if you look at the last five, there's some kind of form, and the first one has to be handwriting recognition. Disclaimer, these results are based on the state of the AI models on May 20, 2020, and have been examined using a limited data set. The results can change over time with newer models or better training of existing models. And finally, based on the communication we received from Amazon in 2020, at that time at least, Amazon Text Track did not support handwriting recognition. So please keep that in mind. Now, this slide breaks my heart. This is 2022, by the way, and Fortune says that we have a failure rate of AI projects somewhere in between 83 to 90%. And in that article, we had this quote, and partially I'm going to quote it for you. Quote, as an industry, we're worse than gambling. Wow. And of course, Gartner says 85% of AI implementations will fail by 2022. Now, when Fortune and Gartner are saying this is definitely legit, and this is definitely something to be concerned about. Now, we were not very surprised that there is a failure rate. However, it is that high was even surprising to us. Just so you know, as a company, Kasten has 100% success on all AI projects, and we help a lot of clients, Fortune 500, large size, mid-size corporation, and quite a few startups work not just on AI but also big data as well as enterprise applications, including web as well as mobile, and scale on different clouds, multi-cloud, and a lot of other kind of solutions. So we thought, why don't we share some of the things with you, and it might make some of your projects better, and of course learn from you where you are doing it better. So if you have any feedback, please reach out to us. So the test is pretty straightforward. We've got 3 different pictures. As you can see, the first one is pretty much handwriting that is extremely hard to read even for humans. The second one is actually almost perfect cursive handwriting, and number third, it's a little tricky, not just because it's 2 different pages, which could be tricky for AI, but it's also because it's French. So we got 3 different pictures, and we're doing it in 3 different languages, by the way, because at the end of the day, cloud is nothing more than web services. So we're gonna actually use Node.js and then Python and then C# to call these different APIs. So let's get started and see what kind of results we get. When we say npm start, as you can see, this is what we get. So instead of dear submitters, it says peer submitters, and that was literally the first result, or the response from the API for the first handwritten image. And then, of course, we'll show you more in detail in the slide decks later, the results, and we'll compare all the 3. Next one, if you like Python, it's Google Vision API, and as you can see, it's barely 20 lines of code, and it's going to run all the 3 images through the same code in a sequential fashion. And just a few seconds, and you can see we're getting the data back. So this is the French file, and right before that, we had the other two. And by the way, it does get dear submitters. Actually, Google got that right. And then, of course, the third one is going to be C sharp. Now we're running this, and you can see there's an Azure link in this particular case, and it's going to the endpoint we have, and we have a key, and it's already running. And I'm going to make a call using Postman. Definitely, you can use my API key. Just kidding. To test everything. Just a few seconds, and we get the result back. And you can see it says letter from Holmes, and then there's a couple of breaks, which is really important because at the end of the day, the structure matters quite a bit. So let's start with having a scalable architecture. It's not that complicated. It's a very generic architecture, especially with cloud. A lot of the pain points are now taken care of. We can use infrastructure as code and literally automate pretty much everything we like to. So one of the things we like to always do is have a gateway and have our security policies at the gateway level. And of course, we're also going to have it at the API, UI, and backend level. But we never start without the bigger picture in mind. And then, of course, right, the gateway will handle the active-active or active-passive load balancing of your apps. And any app we have, we always look at how do we write code in a way that they're never looking at or dependent on something that is locally in there. For example, if your app server locally uses some kind of caching, what happens when the next call comes from the load balancer to another app server? This solution would not scale. And a lot of times, figuring that out later down the line means, oh, wait a minute, we never created a solution that would have actually scaled. So these are questions you got to ask early on before you start creating your solutions. Next, think of an e-commerce website. Let's say I go to Amazon.com, Best Buy, Walmart, or anything similar. And when we are on those websites, really what matters to the user is what they're looking for. Do they really care if the front page loads fully? Probably not. They probably want to go to your search bar and they want to type what they're looking for. For example, if I'm looking for a 24-inch monitor, where do you think the call should go? I think it makes perfect sense for it to go to a document database, which is more on the search or the value side of the story. For example, Elasticsearch, Azure Search, Solar, or anything similar, like even Lucene. And what you'll notice is that it doesn't just have the advantage that you're going to get the results back incredibly fast and high performance, which actually leads to very good UX. There's also other advantages with it. For example, boosting. What if you want to boost a 27-inch monitor that's on sale that day? With a search server, all you have to do is change the boost factor, and now that appears somewhere on top of the results as you wish for the user to have a look at it. And that simplifies your life so much more. What about the ranking algorithm? Again, a lot of those things is something a search database is so much better than a traditional RDBMS. Now, in the cloud world, that's as simple as making another API call to an existing solution. What happens when the user now knows that the person wants to buy the 27-inch monitor, let's say, and let's say it happens to be an LG or a Samsung for that matter? The next thing which you would like to do is now tap into your actual document database, and this could be your Azure Cosmos DB, your MongoDB, Cassandra, Couchbase, or any other document DB of your choice. And why a document database? Why not an RDBMS? Well, the reason is simple, because an RDBMS is not the best to scale out. It's great for scaling up. So it's better to use these two solutions, which in this case are easily auto scale on commodity level machines, and you don't pay a lot of money for that. At the same time, you can scale up to thousands of these nodes in a cloud in pretty much an instant. So what's the advantage? Well, in this scenario, you will have a write once and read multiple times scenario. And in this case, let's say we're getting the results back from the document database. Now, why is it write once and read multiple times? Very simple, because let's just say your Samsung monitor XYZ. Well, that XYZ monitor will have the same specifications from the day it was launched till today. So if you're buying a 2022 model, it'll always have the same specifications as it always had. And that's the same for a 2015 model. Once the model's out, the specifications do not change. What about the comments? Maybe you have 5,000 comments. Do you really want to have the comments in an RDBMS? It actually makes more sense to have verbose data like that, again, in a document database. And if you have to search through those comments, well, you're going to use the search database. So the benefit of this solution is every single thing you see over here auto scales. And as long as you can auto scale, you have a scalable solution. Well, what about caching? Absolutely. You can use Memcache, Redis, or anything else. As long as you have a good caching mechanism, you can definitely use that. What about the pictures and thumbnails? Interestingly, you can use CDNs, especially for something that is public, and you want take advantage of the CDN's geolocation. Again, all of that is easily scalable because CDNs are scalable. And of course, the caching in this case, let's say Redis, that's also auto scale. So far, we do not have any single point of failure, and it's as simple to create a scalable architecture. Now, what about offline processing? Well, take something like what we're going to do today, which is handwriting recognition. Well, if you want to do handwriting recognition, and for some reason you are one of the companies that we work with that might have decades worth of data. In one case, we had a company that had more than 100 years of data that was it was handwritten. A lot of their process could be done offline, and then a human comes in next morning, and they or a group of humans can now look at the data and go, wow, this is perfectly all right, except a couple of places they didn't see what the problem was, or AI says the probability of this is being correct is less than 25%. And that's where the humans need to be involved. So offline processing is an often overlooked benefit that we have, because you can process a lot of things offline without having a user wait for you. And that's another way you can scale your applications. And then finally, what about people who love RDBMS? There's nothing wrong with an RDBMS. In fact, you do get ACID guarantees. And now when I say ACID, it means the acronym ACID. And you can also take advantage of what it's really good at, which is transactional benefits, which, again, going back to ACID, not only do you have those benefits, you can also take advantage of the fact that you get encryption on rest. And RDBMS are a lot of times known to be very, very good about data because they're usually in one machine. So they may not be the best at scaling out. And when I say that, I mean, if you've read, PAC ELC theorem or the CAP theorem, you kind of know that availability, partitioning, and consistency, you mostly get 2 out of the 3. So in this case, maybe your orders data and anything that is very, very serious, according to the cart and order history or customers' data, all of that could be in RDBMS. And there's also different ways of scaling in RDBMS. Now, this is the last thing you want to scale because it doesn't scale out very well. And that's just the general trade-off of being in an RDBMS versus a NoSQL database. But you can still scale it out all the way till clusters level and even use SANs to scale it out. Now, this should be the last thing you ever scale out. But let's say your critical data is here and still needs to be scaled. The benefit of having polyglot persistence or multiple data sources is that eventually, when you have to scale this, you're looking at less than 20% of the data being here, because most of it would be outside. And that said, the talk is really about our AI solution. And in a lot of cases like this, when you're doing POCs, you can still create a scalable solution that is not maybe as complicated as what it was, the one I just showed you. So for example, in this case, you can take a handwritten image, which is beautiful cursive handwriting, make a call to the server, again, with your own gateway. And in this case, you can have multiple different app servers. Let's just take an example of Azure. You would have app services that can auto scale, and you would have them as the second level of defense. And then, of course, with your credentials, whatever you have after authentication and authorization, you are going to be able to make a call to all the 3 different clouds. And that's all you really need. And these calls are happening behind the scenes, and they all have their keys and credentials that you're going to use with the endpoints they have. And here's the good news. Why does this scale? There's really no single point of failure over here and you're also backed by the cloud, as in Azure, AWS, and Google. So if you have to go from, let's say, taking 1,000 of these pictures to 100,000 of these pictures, you don't have to worry about scale because that's the cloud scaling for you. And that's an amazing advantage in the world we live in today. And finally, you get the output and you can compare the two and go, all right, let's find out how accurate it was. Need for scale. This is one thing I touched upon just a little bit, but as you can understand, we have IoT devices, we have a ton of bots out there, we have devices as in tablets and mobile phones and desktops, and with the ever increasing use of technology, pretty much everyone is on tech, and most people have multiple devices, and then you still have the bots and IoT. So scale is something that we'll always have to think of. And one thing to keep in mind is if you can handle performance really well, then scale becomes easier for you. In this diagram, as you can see, relational databases have the most functionality, but they are not the most scalable and they don't have the best performance. And something like a key value pair, something like a memcached, or even a key value pair with data structures like Redis would be very high on scalability and performance, but may not have necessarily the same amount of functionality. That's why I propose polyglot persistence. When I presented at Microsoft Tech Ed Europe in 2014, I doubt the word polyglot persistence was that famous. And we were using this architecture for many years before I'd even done that presentation. And interestingly, the world today is doing exactly like that. And of course, microservices, pretty much all major scalable solutions end up using microservices. So this is a very tried and tested solution that works really well. But one thing to understand is that we do the same in technologies we like. Some people get excited about a certain kind of technology and they start just using it for everything. That's like saying for a person who has a hammer, everything looks like a nail. I think our goal is to make sure that we don't have the bias and we use the right technology for the right use case we have, and it can change. And we'll talk about that in a second. And then finally, anything we do, we create our own benchmarks. As you can see, when we saw that Azure Cosmos DB was, basically claimed that they can do 1 kilobyte, transfers in about less than 10 milliseconds, and that's the guarantee they have, both on reads and writes. We actually ran our own benchmarks all the way from not just 1 kilobyte all the way to 2 megabytes, and you can see the median in the first case was just 5 milliseconds, actually faster than what they were even claiming. So one of the things that I highly recommend doing is do your own benchmarks, so that way you're not listening to someone else's bias that may be out of some blog because they may like a technology over the other one, right? And we do the same for other technologies, the same with Mongo or Cassandra or Redis or any other technology we use. And same here with all the three different clouds, we saw that they all had their own strengths and weaknesses. So how do we start? The first picture, as you can see, it's very, it's a lot. It's not the most beautiful picture out there. I mean, it's handwritten with a lot of errors, and it's easier for a human to read it, but it's going to be quite challenging for an AI, and we'll see that in a second. Second image is perfect. I mean, beautiful handwriting, 116 words and one-page image. And the final one is I could not even read it, and turns out it's French, so that's why. And you notice that we're going to trick the AI because we're going to take an image that has a 2-page image and see how all the three different clouds handle this. So results, the first one, as you can see, this is going to be the hardest one. And the things that stuck out to us was, look at 7, right? We read it and we go 7 as humans, but it is SE7EN. So there's no way the AI would go, oh, it's a 7, right? It's something a human can easily do, but not an AI would. So both the AI, in this case, for Microsoft as well as Google, go SE Zen or 10. And then on the Google side, we noticed that you had inconsequentia, which is not a word. And Microsoft somehow does a spell check and changes it to inconsequential. Now, Google Cloud also has a spell check, but when they do computer vision in this particular case, I doubt they're using the spell check. So that's something you can think of in your solution. If you are on Google Cloud for some reason, you could use the spell check AI along with the vision API and get a different answer altogether. Now, this was really hard. Now, Amazon, you might see a lot of errors. We do not want to penalize Amazon because TextRack at that time, at least, was not supporting handwriting recognition. Second one, this was amazing to see. Like, Microsoft only had 2 errors. So if it is very good cursive handwriting, for some reason they trained it so much better than anyone else that they only had 2 errors. And look at left hand side on Google. It amazes me that the word is jellicitations, and there is no word like that in English dictionary, but Google still goes with that. So same spell check that someone could think of. Finally, the results. In Google, clearly a winner. As you can see in this case, for some reason with French, Google only has 4 errors. As you can see, it's like 3 words they got it wrong on the first line and then only 1 word wrong later. Microsoft's is second, and not bad at all because it's still less than 2 digits. And then, of course, TextRack did not support handwriting, so we're going to discount Amazon for this one. And the second one, wow, Google's only got 1 error. Microsoft still below 2 digits, not bad. Let's look at the results. The first case, Microsoft is the clear winner, 12 errors. Google's got 20. Second case, Microsoft's got 2 errors and Google's got 15 times more errors. Wow, that's a big one. So third one, as you notice, Microsoft's almost 5 times more errors, again, because they just, on French, I think Google was a clear winner. So you saw that there's no real clear winner here, but in certain cases, one is better than other. And then, of course, let's look at Google 2020 versus 2022. So we ran this again in October of 2022 to make sure that we're getting the right, we're looking at how much they improved in, let's say, a little bit more than 2 years. So on the right side, instead of nearest and felicitation, it actually got sincerest and felicitation. So it's gotten a huge improvement and an upgrade, I would say, in 2 years. However, look at this. Structurally, they make a big error. My dear James should have been right here, right below May 15th, like it was. And looks like on the structure, there's something they're doing wrong. And I think this is a big one because if you are going to take this data, the structure is extremely important. In fact, when we do this internally, we give it a weight of 5 instead of weight of 2. And any solution you have, we always like to prioritize, and we have a weight, and this weight is important to us because if we were to use this in an automated fashion, this can completely change what the meaning of this particular letter was. Let's talk about form recognizers. There's a bunch of those: invoice, receipt, application form, and table, as well as some custom labeling that could be done for all the 3 clouds. So in this case, we all know what a W2 form is, and we can have a look at it. And then you can also look at a lot of other areas, for example, your EIN or your address, zip code, and a ton of other fields that you may have on a standardized form. And they all do it a little differently. You can actually try this on your own. You don't even need to call an API to begin with. You can test it on their website, and they'll show you the results, as in this case, Amazon showing you the true positive and the false positive, whatever it thinks it is. And based on that, you can see how you can actually compare all the 3 by just testing by going on their websites. Now, things to keep in mind is the samples. Amazon can work with 5 samples as well as 10. Google needs at least 10. At least then, in 2020, it needed 10 forms to even start doing the training. And Microsoft, of course, could do 10 as well as 5. And one of the things we really liked with Microsoft was it only took 5 seconds for 10 forms. And their tool was pretty incredible because you could actually get a lot more data from this tool while you're doing it, and it's gotten a lot better. Let's look at the results. Number 1, Microsoft for bounding boxes with OCR. They were the only ones in 2020 to have that. And then if you notice 5 samples, Google doesn't do that. Google needs at least 10. But Microsoft with 3 seconds of training versus 52 minutes of training, that's almost an hour. So you can see 3 seconds versus 52 minutes. Microsoft only has 1.5 regions unidentified, and Amazon's got 3 regions unidentified. So definitely Microsoft's a big winner here. Take number 2, which is 10 samples. Google is the only one with 100% accuracy. So it identified every single region. Now, this is where I say, you got to be careful how you make a decision. Now, if accuracy is the most important thing for you and you can wait 1 hour 14 minutes to get the training uh, happen, in that case you're perfectly fine with going with Google. Now if you want something real, real time, which is like 5 seconds, and you're okay with 1.5 regions unidentified, Microsoft may be your solution. But in this case, with barely any training, just 10 samples, Google got full accuracy 100%. So definitely a clear winner in terms of accuracy. And of course, Microsoft definitely a clear winner in terms of time taken. And then finally, in voice recognition, this was great. I think Amazon was the best here. Amazon, by the way, quantity for some reason, I don't know why no one got it. And Amazon gets everything else really well. And OTY is not that bad. I think they're almost close to 100% accuracy here, which is pretty incredible. And then Google, for some reason, misses the ones. That's it. Nothing bad. Again, very well done. Microsoft misses a bunch of ones, and in that case, they miss 4 for some reason, and everything else is pretty similar, not bad at all. But you'll notice that Amazon, it's a clear winner, and Google's got twice the errors, and Microsoft's got 4 times the errors. So for some reason, invoice recognition on Amazon beats everything out there. And then, of course, receipt recognition. We had our interns get a receipt that's pretty natural. It's a little curved, as you can see, so it's not that easy to handle it. But we were surprised to see things like pound becomes 1B instead of LB. And then anytime you see a bounded box with yellow or orange color there, it is more because the structure got changed a little bit. So Google, surprisingly, I don't know why, but Google receipt recognition misses the structure quite a bit, and that is definitely a big downside because structure, as I mentioned earlier, is very, very important in any application whatsoever. And then Microsoft, in this case, definitely has that one structural issue, but it's very minimal. It's almost like it's one line below, as you can see. It's not that bad. And then, of course, 1B and LB, for some reason, same exact issue. So now, if you look at the data, right, Google only has 2 errors and Amazon's got 8, but Amazon actually wins on the total score because the weighting is more on the structure, and Google messes up structure thrice, and Amazon only once, and so does Microsoft. But Microsoft also has a pretty low error count. It's 2 and 2. So Microsoft's a clear winner here, 7, and AWS is 13, and Google 17. But keep in mind, if you're only looking at error count, Microsoft and Google end up actually winning. But if you're looking at structure, it's basically Microsoft and Amazon. Now we're going to look at the forms, but since Amazon did not have handwriting recognition at that time, we're going to keep Amazon out of it. But you can see again here, in the first case, errors made were 6 and 9, and structural errors were 1 each. So it's pretty competitive, both of them. 1.5 times more error, not that bad. But look at number 2. Interestingly, the structure error in case of Microsoft was 0, but the actual errors were a lot more than Google. So you notice that in some cases, in this case, Microsoft's got twice the amount of errors than Google for the same exact application, just a different data set. But the structural error was lower, so it's pretty tight. I would say that they're almost as good as, I wouldn't say there's necessarily a clear winner here. They're both pretty similar. And again, if you have more data, the results might change. And then finally, table recognition. This looks really hard, but it's actually really easy to do, especially with computer vision, because most of it is just numbers. And that happens to be the easiest thing out there. If you've ever done MNIST or something similar, you know that the success rate is pretty high, and you will notice that in the results. Number 2, all of them got full text accuracy. That's 100% accuracy. In the number 1 case, I'm not sure why this happened, but again, I think more important is to look at number 2, because that means with barely any training, all 3 of them were able to get to full text accuracy, which is pretty incredible. Now, number 1, of course, Google definitely was winning, and number 2, everyone got to the same level. Finally, references. I highly recommend reading the executive blog. We write this blog where we simplify all the technology to make sure that even non-technical executives are able to read it and go, oh, I understand exactly what's happening. We try to take all the complexity and push it behind. And a technical blog, we get all the way to, talking about TCO comparisons, as well as performance, as well as, scalability, a lot of other things. If you want to read more about these 2 reports, you can actually read a lot in detail. If you'd like to leave us an email, you can download these reports with a PDF. If you choose not to share your emails with us, that's perfectly all right. You can still read all these reports completely free on our website. Thank you so much for the opportunity. Thanks to all the organizers, sponsors, and fellow speakers, as well as the attendees of the conference. If you'd like to connect with me, you can add me on LinkedIn. And of course, if you need to know more about or have further discussions about this, please feel free to reach out to our team at info@caston.com. Thanks again, and have a great day.